Today I'm going to be talking about some interesting projects that Wolfram Technical Services team has done. Of course, you would notice that we're calling it Wolfram Global Technical Services. And the reason behind that is initially when Technical Services team came into being, there was just one team. And we actually grew very rapidly. We saw a lot of success, and not just success in terms of numbers, but also in terms of the results that we could actually get to, and the customer satisfaction, number of people who became interested with the newer kinds of things, that the great things that they could do with Wolfram Technologies. We became like partners, and what that led to is starting an entire new group in Europe. So they are called Wolfram REL Technical Services. We are the global team, so we cover North America, South America, and Asia and Pacific and all. So everything except for Europe, and that's why you see that term global there. Of course, the projects that I will be presenting today, they're all done by the Global Technical Services team. REL has done their own projects. They're not included here as such. And let me tell you, Prati, that the idea behind this presentation is to basically paint the picture of what kinds of things can be done using Wolfram Technologies. I may not go so much into the details of exactly how we did that. Of course, if you would be interested in that, then feel free to catch me after the talk. We also have a technical services booth in the basement. We are available there for any discussion that you may have. It could be, to know more about these projects, or it could be about discussing your own project ideas or challenges. You're welcome. So starting, how many of you already know about the technical services group and the offerings that we have? So majority doesn't. So I'll go through the first three slides very, very quickly. We have three major offerings through the technical services team. First, we call as project support, which is like, standard consultancy kind of work, where customer provides us with specifications and data. We come up with a cost estimate for that, and if that fits customers' plans, we determine the deliverables. We do entire design, implementation, deployment. We can also do support. And of course, what I'm also mentioning here is that we have tried to keep it very flexible. So even if a cost estimate is given, but we end up doing it, in smaller amount of time than the estimate, then you get automatic refund. So that's very useful. But the last point I would like to emphasize on, that one can sign up for, in multiples of 1 hour, which is that it's a very, very small amount of money that's involved. But the idea is that one should not feel hesitant approaching us. It could be like 1 hour of brainstorming with us, just 1 hour of discussion, or 1 hour of technical, help that we can provide. The second offer, which is somewhat contrasting from the first one, is that in this case, we do not ask for specifications a priori, because I personally came across several customers where they themselves were sort of evolving in the process of identifying what they would like to have. They know that there are certain problems, so there are certain gaps in the workflow, or whatever work that they're doing. So we work with the customer as the process actually evolves. So that has become extremely popular now, because we work as an extension of their team in a collaborative fashion. So in one sense, if you're using Wolfram Technologies, then you always have a team ready to help you with that. So that's what actually differentiates this from project support. Of course, we also do advanced training. So if you want to learn how to do your projects all by yourself, then we'll provide that training that could be related to specific domains of knowledge. Of course, we don't just tell you exactly how each of the function in Wolfram language works, also the according domain knowledge that is required to use those functions in most effective ways. And I'm putting this up here for a reason. So this refers to, the revenue that we had, sort of the breakup of the revenue we had in 2015. You can see that project support had the largest chunk because that's more traditional model. But as I said, I've been recognizing more that customers are looking for partners, with who they can come up with ideas and try things out and implement. So if you notice the proportion of development support, which is that kind of work, this is actually growing. I'll not be surprised at all if actually this becomes more than 50% of our revenue altogether. Again, the idea is that you always have a partner to work with you. So let me get started with some of the examples. Now, one thing I should mention here is that whatever concepts that I'm going to be talking about, they are inspired by the problems that our customers have faced and the projects that we have worked on, but then they are not like one-on-one match. And the reason behind that, obviously, our customers have NDA with us, and they would like to keep that niche with themselves. The business advantage that generally comes with the ideas that they carry. So I'm going to be presenting more in terms of concepts, but these concepts are not at all theoretical. And on the other side, these are all that have been implemented using Wolfram technologies and have been done actually quite effectively. So in this particular case, this is like a performance analyzer platform. We found that lots and lots of companies are actually collecting lots and lots of data. But amazingly, majority of the companies are not able to use that data effectively at all. Not just effectively at all. And the reason behind that is that data is in disparate repositories and in very different types of formats and managed by different entities. In fact, just day before yesterday, we had a 3-hour-long meeting with one of the largest companies in the world, pretty much in terms of their revenue. I can't name them here. But they work with probably 100 different consultants. And consultants are actually managing the data. And to get one view of that data may be 1 month of work for them. Why? Because they have to go to the consultant, convey to them what's required, and then the consultant starts putting the data together and all kinds of situations. That's why they have come to us. And we are in talk to develop an integrated platform for them. So here, as you can notice, this is giving a view into a data set where different, it involves different buildings in this concept. It could be any entity. It could be any property, as you can see here. And there may be, hierarchies of entities, like regions and then sub-regions and then customers and then employees and whatnot. Of course, you're familiar with the more interactive kinds of features that Manipulate comes with and such. So, those features are available here. But what makes it more interesting is that the amount of data that we are talking about here is extremely large. It's not in a, it was not in an integrated platform as such. So what we did is we basically developed a data architecture for this company. And so the way it works now is that data is getting fed in on a daily basis. And every night, the backend of this system actually crunches that data, aggregates it, stores it in a particular format, but in addition to that, also develops models and then stores those models. So when the end user comes in, which may be officials from this company, they can get this snapshot very, very quickly and easily. And remember that this is actually connecting to data source. This is, of course, just a conceptual presentation, but the actual system is connecting to a data system or a data repository which represents the entire country. an entire big country, but then getting the snapshot is actually as fast as this. And of course, we provided for different controls over that. What they specifically asked from us was be able to get to any view of this using those controls, be able to get the data out, get the plots out, get the stats out, so that they can then use it for business intelligence kind of situations or reporting and such. Of course, comparing different properties associated with those entities, that's extremely interesting to them. So in this case, as you can see, we're choosing certain specific entities and then certain properties, 2 of them, and then comparing that with, of course, similar options related to exporting the data and such. Times versus flow, this was of direct importance to them because, again, they wanted to see how the correlations actually work in terms of these 2 parameters. So again, this is feeding into the large data set. This is a very interesting view. They call it differentials. What basically it's doing is that it's taking data from a certain period and comparing that to another period. And this is where the model comes into picture, because any real world data, and that they're not going to come at the same frequency, their quality is going to be different and such. But when you want to do differentials, then you need the 2 data sets to be uniform. So those models come in handy here to be able to do these differentials. Now what we are looking at looks random. And that's the good news for this entity. They want to see that the differentials actually should be random, because if there is a certain trend, then they need to take an action. It could be a positive thing, but still they need to know what actually they're talking about. Now you can see this is a very interesting view. This shows the original data set, and these are the differentials. So although there was a clear jump in the magnitude here, but the differentials actually still remain largely random. Of course, we can apply statistical tests to these for test of randomness to make sure that we are not missing something just because we are looking at visually as such. That was not done in this project, but totally doable. So that is one idea. Again, what is terrific about this system is the way that we architected the entire data structure and the speed with which we are able to make these queries. So I'll move on to another example. This is a startup company called bioengine.com. We took permissions from them to share their name. Of course, they were happy to be mentioned here. You can go to bioengine.com if you would like. They have come up with a very, very innovative idea. In fact, it was way back in 1940s that Paul Dirac came with the idea of bra-ket notation. Some of you who are from physics background or quantum mechanics background, you will be familiar with that. But they are applying that to health data, to health industry data. And of course, it can be applied to other domains as well. The idea behind this whole direct network, as they call it, is that if you can represent vast amounts of data, which may be quite unstructured in the form of these bra-ket notations, and then build what is called as HDN, hyperbolic direct network, then there is a lot of information that can be derived from that network. That information gives you probabilities of different scenarios or different properties, and that then can be used for diagnostic purposes. So in this case, again, this is dealing with large amounts of data coming from different health providers and such. So what we are showing you here is actually a prototype. We are in phase 2 of this prototype. They first wanted to check just the core of the technology, how well that can be implemented in Wolfram language. And now what they're going to do is we are in the process of deploying it in the cloud. And within another 3 to 4 weeks, in fact, they'll be opening it up to public for so that public can play with it. In fact, what's going to be very, very amazing is that public will be able to upload their own data set, which doesn't know anything about bracket notations or anything like that. But the system will process that. And of course, we are providing some extra controls for that reason, because you're talking about large amounts of data. How much of data you want to process from your data file, certain limitations or that you may want to put just to save on time and such. How many variables you want to be working with. And just to give you a sense of things, here we are saying maximum number of columns being 46. But generally, the data sets may have as many as 150 to 200 different columns, different parameters that they have to work with. And in different scenarios, they may like to actually select or deselect different properties, given what kind of inferencing that they want to do. So as you can see here, what happens is that from the first screen, we selected a certain sets of columns that need to be processed. Then the system actually goes back and processes those columns and creates what is called as a tag pool. And it's like a gigantic pool. We are talking about gigabytes and gigabytes and gigabytes of tag pool that is created. Now, this is what actually made this application very challenging from implementation point of view, because imagine, the number of variables you may be working with is 150 or 200, and then, that's the original data set, and you may be pulling out, let's say, 90 of those variables that you want to deal with it, and then you may want, 5 or 6 different parameters that you need to operate on and such. And this works with, combinations of the properties. Yeah. No, these tags actually correspond directly to the properties that you're working with. So these are not the standard tags that you're talking about. And they call it tag because that's how the probabilities get calculated. So it's like any piece of historical health data that you have that has a certain information content to it. That tag represents, so one piece of data, let's say one row, may have 5 different tags or 20 different tags associated with it. What it means is, whenever there has to be an inferencing done for any set of properties, these are the pieces of data which are going to be contributing to that inference. So that's the idea of the tag there. Anyway, so what it does is creates that tag pool. In this case, as you can see, 1.7 million tags were created, and this was just a test data set that we were working with. So we could be working with like hundreds of millions of those. Of course, there's a prototype. We wanted to show what are the variables that you're working with at this time. I think they should add up to 46 that we showed on the previous screen. And then what's interesting, now this looks a little bit geeky here, but this is the kind of query that can be passed on. This is a very, very simple query. It can be much more complex. And if you notice that we have provided this much of space because the query may run this long. So the idea here is, person with age 30, male, glucose level of 80, smoking, given that he does smoke and his systolic is around 120. Of course, when there is a continuous variable, the system is intelligent enough to break that into bins and then work with those bins. So queries like this can be made, and that the system is going to return what are called as Zeta probabilities associated with that hyperbolic direct network. So these are the Zeta probabilities. Of course, this is forward and this is backward probability. What that means is A given B is forward and B given A is backward. And this does not use the classical probability system. It uses Clifford probability. In Clifford probability, your probabilities can go beyond 100%. But that's how that works. Now, one may say, well, this does not seem very interesting from users' point of view. This is actually a very, very important milestone, because beyond this, what we are going to do, that's like phase 3, is that there will be another layer added to this system where the end user will be able to ask questions in plain English. Then the system is going to convert that into query in the form of bracket notations. And that's going to then work on the tag pool and develop and come up with those probabilities. So eventually now you can see a direct correlation with the kinds of diagnostics that can be done. Of course, along with that, you may like to understand what the data looks like, what are the properties associated with it. So as you can see, these are different fields. You're looking at counts and descriptive statistics. In addition to that, we provided for being able to look at specific demographics. On the first screen, you could choose which variables you want to use for demographics, and then select and get views out of the data. That's for better understanding, that's for diagnosis, and so on. Of course, getting some visualizations out of that, and so on. This gives the probabilities associated with the data set. So this can be a diagnosis on the data set itself. If, let's say, it is between male and female, and you see, like in this case, here. So we see that there are actually issues associated with the data set, and it is intelligent enough to recognize that there are unknown values and how that needs to be handled and such. Again, this is interesting. This automatically generates this correlation network of different variables, and the density of these edges in representation, that represents the strength of the correlation. One can go back and click on one of them, any of these, and get the according correlation out. So this is correlation between systolic BP and waist circumference. So all people like me, they're here. That's very good news, because future looks bright. There's another company, very, very interesting company called Healthcare TTU. What they have done is, in the health industry, there is, again, a lot of data being collected. However, when it comes to the claims that are made, like you go see a provider, and then they send a claim to your insurance company, then there is a repayment. Sometimes it's not done because your insurance company does not cover it, or let's say insurance is not there in place at all. So all the expenses that public incur from these health providers, there is a lot of uncertainty associated with repayment of that. So claims are certain, but payments are not. And you cannot do business if you do not know whether you're going to get your money back or not, or you do not know how much money is going to come back, and even if you do not know when that money is going to come back. And the situation is, and I was a little bit surprised that that's how it is as of now, even today, but it's a fact that it's a mess. What it basically leads to is that the health providers are dealing with very, very difficult scenario in terms of what they can expect in terms of the revenue flow. And the banks are very hesitant touching on that because they don't know how much risk is involved. So what this company has done is that they have come up with a very, very innovative idea to fill that gap. And basically what it does is, again, there are historical claims data, which includes claims and repayments in instances where repayments have been there. They basically collect that data, create a very large pool, and then they model that data appropriately. And I'm not free to tell you exactly how that modeling is done, because that's what this company is going to earn from. They are already. And they convert that pool of claims, which are still unpaid, into an asset. That asset comes with a known probability of repayment, and I'll talk a little bit more about it. Once that's quantified, then banks can deal with it. They know how much of risk is there, what kind of revenue flow they can expect, and then if banks are then on board, the hospitals are going to get their money, they can continue operating. The fact is that Many of the hospitals are shutting down their emergency care rooms because they have not been able to deal with this. And what we have done is we worked with the CTO of this company, who is basically the brain behind it, and implement the entire model. This is just a snapshot that he gave me to share with you. That basically tells us the time frame, this is timeline, at which we can expect that much of repayment. So this is like 30 days, 60 days, 90 days. And the second thing that I talked about is what's the risk associated with that particular asset. So bank can use this directly. So I'm going to just give you another 1-minute overview of the last example. This is conceptual, although again, we have done something very similar. All the companies, they have different teams, different workflows. Then either we go pick an off-the-shelf product and work with it, or just keep it manual. So what this company did is, let us not do that. They came to us and asked, can you create a custom product for us, which takes into account our workflows, our needs, and then automates it as much as possible. Again, here what we are showing you is, this is, for example, dealing with clients, some mundane things like scheduling meetings. Of course, you have different tools to do that. But what about an integrated system? And here is why. This blank thing can be all the products or offerings, services offerings that you have. And what this system basically does is that it allows you to go through, to provide all those data and information. Just for an example, when work comes to you, mostly it's in the form of emails, and then you go back, create your to-do list. Imagine a team which is working with this kind of system, and some teams are already doing it, by the way. That gets automatically triaged by the system. When when you reach your office next day morning, it has a ready-made to-do list for you based on all the requests that have been made. It has the collection of all the data and information that you may be working with. You're sitting with your client or your customer, and you will have all the information in one place. Not only that, it is built in with, in this case, it was built in with specific logic that they use to offer different products. So even as, let's say it's a salesperson or it's a manager, they're talking to the client, they're getting automatic recommendations of the products and services that they can offer. So it's amazing because as he's busy talking, the system is helping him with all the resources and decision making. So anyway, that was the last example. I think we have run almost out of time.